Okay everyone, welcome back to our tutorial video on rational expressions. Okay, so before we proceed, just like we promised last time in our first video, we will first check, okay, the one that I gave last time for homework or for city work. So let's do this one. Okay, so if you're able to answer this, so you can check your work. So we're asked to find the restriction of the following expressions. So for number one, okay, obviously, this expression will be undefined if x is equal to 0. So x should not be equal to 0. For number 2, so that will be, we get the denominator and equate it to 0. So we have x is equal to negative 13. So this will be our restriction. So we cannot use negative 13 because the expression will be undefined. For number 3, so 2a plus 1 equals 0. So this one will be 2a equals negative 1. Then divided by 2 for both sides. So you get an a equals negative 1 half. So it's okay to have an answer that is a negative or a fraction. So you cannot use a negative 1 half for the value of a. Again, remember that we are just getting the denominator because that is how we can determine if our expression can be undefined if it's over 0. Okay, the next one requires you to recall, okay, factoring also. And if you remember this is what we call in acronym dots. This is the difference of two squares. Okay, so that becomes a squared minus 1 equates still to 0. And when we factor that, we have an a plus 1 and a minus 1 equal to 0. And then we equate each to 0. We have two factors. A plus 1 equals 0. And the other one is a minus 1 equal to 0. Therefore, the restrictions we have here, we have two. X should not be equal to negative 1 and positive 1. So it's possible to have two or more restrictions. Okay. Number 5. This one is factoring also a quadratic trinomial. This is x plus 4, x plus 1. We will review more on that later for the factoring. So this is x plus 4 equals 0, which is x negative 4. And x plus 1 equals 0, so that's x equals negative 1. So x should not be equal to negative 4 and negative 1. So again, in this one, we have two restrictions. Okay? So just a hint, um, the exponent of the variable sometimes tells us how many restrictions we have. For example, here in numbers 1, 2, and 3, all exponents of the variables is equal to 1. That's why we only have one restriction. For number 4 and 5, the exponent of each variable is 2. So which means we have two restrictions. Okay? So we now proceed to our next lesson, which is simplifying rational expressions. Okay, so let's recall first, how do we simplify fractions? Okay, example, let's have a 12 over, let's have 20, for example. Okay, so usually we just get the common factor for each and then we divide them, right? But we can actually do also, we get the prime factors of 12, which is 2 times 2 times 3, and then the prime factors also of 20, which is 2 times 2 times 5. Okay, and what we do is we can just cancel out common factors. We can cancel the 2 here and another 2 here. So what's left now is just 3 over 5. Okay, we can cancel common factors. Okay, and then the numbers that are left will be already our simplified form. And that is also how we can simplify rational expressions. Okay, let's have some examples. Let's start with a review of laws of exponent. Okay, if we have x squared over x raised to 4, for example, if we try to write the factors of each, that's x times x, and x times x times x times x. And then we cancel common factors. That's why we get here 1 over x squared, or by simply subtracting the exponents, right? So that is how we use to simplify exponents of the same variable. So same process will also go with rational expressions, like if we have a 2x over a 6, okay? So the factors of 2x is just 2x. There's no more prime factors for 2x. And then for 6, we have 2 times 3. So we can cancel the 2 here. Therefore, the answer is just x over 3. So x over 3 is the simplified form of 2x over 6. Okay? Let's have another example. Okay, let's have this example. 12a cubed over 9a raised to 5. So the factors of 12, prime factors of 12, we have 2 times 2 times 3 times a times a times a for a cubed. And then for 9, we have 3 times 3. And then for a raised to 5, we have a times a times a times a times a. So we can cancel the common factors 3 and 1 pair of a here, another pair, and one more pair. So what's left now on the numerator, we have 4. We can multiply now what we have left in the numerator. That's 2 times 2, 4. And in the denominator, we have 3 and then a times 8. So that is 3a squared. So this is now the simplified form. Okay? But usually, most of you are just doing the shortcut method, wherein you just find the greatest common factor of each number or numerical coefficient and just divide them for both. For example, between 12 and 9, the highest number that I can divide them is by 3. So you will divide both of them by 3. So 12 divided by 3 is 4. And then 9 divided by 3 is 3. In terms of the variables with exponents, we will just follow the laws of exponents. This is on quotient rule. So we can just subtract 3 and 5. Okay? And it will give you a negative 2, which means you will put that in the denominator. You can do this method, especially if the numbers are too large or if the exponents are too big, okay? Big numbers, exponents. Because if you do that, for example, you have an a raised to 100, you don't write the 100a's here. So you can just subtract the exponents of the same variable. Okay, let's try another one. So here, if we can just do the shortcut method and find common factor, we can divide to 65 and 35. We can do that. So we can divide both of them by 5. So 65 divided by 5 is 13. Okay, and then 35 divided by 5 is 7. Okay, and then with the variables, we have your a squared over a squared. So that is 0, a to the 0, which means, remember that a to the 0 is equal to 1, or any variable raised to 0 is equal to 1. So that is just cancelled out. With b cubed over b raised to 4, that is b raised to 1 in the denominator, or just b. And then if you notice, b doesn't have any in the denominator, so we just copy that in the numerator. So the final answer now is 13c over 7b. Okay, so let's try another one. This time, we have a binomial in the numerator, 2a plus 2b over 6. Okay, common mistake here is, some of you might think that we can cancel the 2 and the 6 here because they have a common factor of 2. Okay, take note that we can only do that if it's a factor. 2a and 2b, this is considered as one expression. So this is just one factor. So we cannot cancel that with the 2 here. So what we can do here first is we factor the numerator. So in this case, we will be doing the HCF, or the highest common factor of the term. So between 2a and 2b, the common factor is 2. Okay? And to get the other factor, we will divide each of the term by 2. So that is 2a divided by 2, you get an a, plus 2b divided by 2, you get a b, over 6. To check if this is correct, you just distribute the 2 to a and to b, and you will still get the same expression. Now, that's the time for you to simplify the 2 and the 6 here, because 2 now is a factor of the expression 2a plus 2b. So that will be now, by dividing them by 2, both of them, so that will lead us to a plus b over 3. So our answer now is a plus b over 3. It's also possible that the numerator can have more than one term. Okay, for example, this we have the numerator has 4 terms and the denominator has 2 terms. So in this case, do you remember how we can solve or factor the one in the numerator? If you're thinking grouping, yes, you're correct. So we can group the numerators and the numerator into 2x plus 2y and then plus xy plus x squared. When you do the grouping, make sure that at least one of the group has a common factor. For example, 2x and 2y, they have a common factor of 2, and xy plus x squared, they have a common factor of x over 4x plus 4y. After we group them, we can now get the common factor of each group. For the first group in the numerator, the common factor now is 2, and then we divide each of the term by 2, so that's x plus y. The next group, common factor is x. So when we divide each term by x, that's y plus x. Over the common factor between 4x plus 4y is 4 times x plus y. But we're not done yet. We can't cancel the x plus y here because this is still a addition. Okay, we need to get the factors. So if you notice in the two terms here, this term and this one, they have a common factor of x plus y. Take note that x plus y and y plus x are just the same. So we get the common factor x plus y, and then we divide each by x plus y, so we will get on the other factor 2 plus the remaining term, which is x, over 4 times x plus y. Okay, if you notice now, these are now factors wherein we can cancel. X plus y and x plus y can be cancelled. So the final answer would be 2 plus x over 4. Question, can we still cancel 2 and 4? Okay, the answer is no, because 2 plus x is just one expression here and it's not a factor. Okay, so that will be our final answer for the expression when we simplify it. Okay, good. Before we continue, let us recall first the different factoring techniques that you learned from your math class last year or the previous years. So we have the first one, which is the difference of two squares. We have the cube, difference of two cubes, and the sum of two cubes. We also have the perfect square trinomial. We have also the quadratic factoring, where a is equal to 1. And the last one is also quadratic factoring, where a is greater than 1, or it can also be less than 1. Okay, so these are the things that you need to remember when simplifying rational expressions. Okay, so let's try now this rational expression wherein we can apply also the different types of factoring techniques. Okay, so for the first one, x squared minus 9 can be factored using dots or difference of two squares, which is now x plus 3, x minus 3. Okay, take note that these two can interchange. The next one is x squared plus 5x plus 6. I am fond of using the window technique whenever I teach factoring for quadratic trinomial. Okay, so let us recall, how do we use the window method or the box method in factoring quadratic trinomial. Okay, first we write here the first term of the quadratic trinomial x squared. And on its diagonal, opposite diagonal, we write the last term. Okay? And then to figure out which number or terms will be placed on the other two, we need to multiply x squared or the first term and the last term. So that will be 6x squared. So this is now the challenge. We need to find two numbers when multiplied, it's 6x squared. That's the first condition. The second condition is those two numbers must also add up to the middle term. In this case, the middle term is 5x. Okay, can you think of a number now that can, the product is 6x squared and the sum is 5x? If you're thinking 3x and 2x, that is correct. Okay, so when we multiply 3x and 2x, it will give us a 6x squared. And when we add 3x and 2x, it will also give us 5x as a result. Therefore, we put here those two terms. And also, these two terms can interchange. They are interchangeable. Okay, so we get now the common factors of the horizontal and the vertical side of the window. So for this side, it's x squared and 2x. So the common is x. On this side, we have 3x and 6. So the common is 3. And the one on top, we have x. Here, 2x and 6, we have 2. So these are now our factors. So the factors now are x plus 3 and x minus 2. Sorry, x plus 2. Okay, they are now written in factors, so we can now cancel the common factors, which is the x plus 3. So what's left now is x minus 3 over x plus 2. So this is now the simplified form of the expression. Let's have now our last example for this video. Okay, the last one is x squared plus 7x minus 8 over x squared plus 10x plus 16. So again, I will be doing a window method to illustrate how to factor the first expression in the numerator. We have x squared, we copy the first term here, and this is the last term. Okay, and then we multiply. So we have x squared times negative 8 is negative 8x squared. Again, our first condition, we need to find two numbers. When multiplied, it's negative 8x squared. But when we add, it should be the middle term. The middle term of the expression is 7x. So there are two numbers that we can use here, or two terms. You can use 8x and negative x, or negative 1x. So check, if we multiply that, that will give us an negative 8x squared, and when we add, it will give us a positive 7x. So we can place here the negative x, and here is the 8x. Same process, we get the common factors now. This is x, here it's 8. The one here on top, this is x. The one here, there's none, so it's 1. Okay, so how do we determine the sign of the term? Now, you will just get what is the nearest to that term. Because for 1, the nearest operation here is negative, so we make it negative. A while ago here on x and on 8, because the nearest sign of this is positive, so we get the positive sign. Negative is too far from our answer 8, so it will not be negative. Here, 1, it's near negative, that's why it's negative. So the factor of the numerator is x minus 1 and x plus 8. Okay, let me just erase this so we can write here again. So next now is we need to factor the denominator. Okay, we will still be using, because it's still a trinomial, we can use again the window method. But I know there are other methods that you can use. We have the AC method, you have a trial and error, you can do those things. Okay, so for the second one, I'll have here the first term is x squared. We have here 16. Okay, then we multiply. I have 16x squared. I need to get a factor of 16 that will be equal to 10x when added. So the two terms are 8 x and 2x, right? When we multiply, 16x squared. When we add, it's 10x. So let's put 8x here. Again, you can put anywhere those two terms on the remaining quadrants of your window. Okay, you will still get the same answer. So for this one, you'll get the common factors x. Here it's 2. On this part, we have an x, and here is 8. So the factors now are x plus 2 and x plus 8. And now we can cancel out common factors, x plus 8, x plus 8 here. So we have now the simplified form of the expression, which is x minus 1 over x plus 2. Okay, so I hope this helped you in your lesson for rational expression simplifying. Okay, on my next video, we will have more on the simplifying using other techniques in Factory. Okay, see you next time.